Let's start with something really simple. The equation y equals x squared. We all know what x squared means. It's x multiplied by itself. But you can also think of x squared as x added to itself, x times. For example, 4 squared is 16. That's the same as 4 plus 4 plus 4 plus 4. 5 squared is 25. That's 5 plus 5 plus 5 plus 5 plus 5. So we can write a general equation, x squared equals x plus x plus x, and so on, x times. This seems perfectly correct. Now let's do what we do in calculus. Let's take the derivative of both sides with respect to x. Let's start with the left side. That's the easy part. Using the power rule, the derivative of x squared is simply 2x. So far, so good. Now let's look at the right side. We have a sum of terms, x plus x plus x, and so on. To take the derivative of a sum, we just take the derivative of each part, right? The derivative of the first x is 1. The derivative of the second x is 1. The derivative of the third x is 1. And we do this for all x terms. So the derivative of x plus x, and so on, equals 1 plus 1 plus, and so on, x times. And what do you get if you add the number 1 to itself x times? You just get x. Now let's put our two sides back together. The left side became 2x. The right side became x, so we have the equation 2x equals x. Now as long as x is in 0, we can just divide both sides by x. And we are left with the impossible conclusion 2 equals 1. So what happened? 2 obviously does not equal 1. Where is the mistake? Did you find it? The flaw is very subtle, and it happens right here. When we take the derivative of x plus x plus x, the problem is that you cannot just differentiate each x term individually. Why? Because the number of terms you are adding is not a constant, it is the variable x itself. When you write x plus x, and so on, x times, you are not writing a simple sum. You are writing a product, x times x. And to take the derivative of a product like x times x, we must use the product rule. That's the derivative of the first x times the second x, plus is the first x, times the derivative of the second x. This becomes 1 times x plus x times 1. That's x plus x, which equals 2x. So the equation should be 2x equals 2x, which is always true. The paradox is solved. Did you spot the mistake before I revealed it? Let me know down in the comments. Thanks for watching. If you like to challenge yourself every now and then with math equations, subscribe.